Hello everybody, welcome back to From Rhythm to Algorithm. As you can see in the previous episodes, we've completed ordinality, we've described or derived and described everything that could be described as an ordinal number in proper mathematics. So I have some theorems down here and then another conceptual big proper mathematics kind of identification. But we'll go through the theorems. Some of them might sound goofy or not, I don't know. But because we've completed, again, the ordinal numbers are ordered, and what is ordered are the phase changes of physical systems. And so with that was the direct kind of intuitive logical derivation stopping point, and then I wrote all scalars are cardinal. And we'll get to why. Again, this might not make sense. But just again, these are theorems, it doesn't really matter. An exponent is an nth power. And so again, logically, we derived that if you have an ordinal number, and then we have to tighten up again the verb, noun. I mean that something's still not complete there. But regardless, when you put ing on any ordinal number, it generalizes to a cardinal number, and then the word thing. And we've derived everything literally from things. And so we did this from a direct physical motivation and direct physical first principle. Nothing is touching, but everything is connected. And so, right, when you're talking logically about exponents, right, you say an exponent is the nth power, right? So then all exponents would be ordinal numbers. And so we've kind of like solved all exponentiation or something. Again, I don't know what the consolidation is, but we'll get to it when it arises. Exponentiality is ordinal. Exponential, potential. All exponents are ordinal numbers. Cardinality is not exponential. And so intuitively, again, like why is there any sort of difference between an ordinal number and cardinal number to begin with? So ordinal number, again, logically and linguistically, very similar to order, makes sense as to where that comes from, but a cardinal number, right? Is that a bird? Is that a pope's best friend? Where does that etymology come from? I don't know. But again, just what logical difference is being made. And so everything is kind of time dependent, but these phase changes, like when we're in this environment, two stabilized physical components and this open thermodynamic system where we're all exchanging, we're all radiating. And so we don't technically live in 3 dimensions. We live in a stabilized 2-dimensional, I explained it well enough as I could last episode. There's 2 components stabilized and we're in this open, and all the energy is exchanging in the same way you put water on the stove, and during the phase change, when it's going from ice to liquid or liquid to gas, all of the energy goes to the phase change. And the temperature of the system doesn't change. And so temperature is universal. The microwave background, that's what that is. We've derived that logically. But that wasn't that big of a new step. So the difference, cardinality is not exponential. And so pairing to these ordinal numbers of these extreme growth periods like inflation. And so there's some, again, geometric reason, again, the physical properties not knowing the other physical properties. And so it's just a fundamental difference. And that's why you have, up, down, left, right, positive, negative charge, more specifically. But then I still think magnetism is more fundamental, so to speak, than charge. Linguistically, charge looks more well-defined, but it's just more generalized. And so I'm not trying to get too much into the physics right now, just kind of sticking with the mathematical developments. But again, it all comes at once. And right now, again, it's like there's a bunch of intuition for me where I'm just trying to, piece together what part of the proof this goes to. But again, what is cardinal? What is that descripting? What is that differentiation made already in proper mathematics? But it is not exponential. And so again, I just think it's pairing to when you have the inflation period of the universe, that's extremely rapid growth. When you have puberty, that's extremely rapid growth. What I've called R3 up until this point, but I'll continue to call just for you get what I'm saying, is that, again, all of these cardinal numbers, quote, I'll put those even in quotations, all of the non-ordinal numbers are, again, just within, they don't represent physical growth in the way an exponent does. and that's very literally consistent. And so it's just kind of like the rapidity of growth. Again, addition and multiplication, there's a clear like difference in like how rapid those functions develop. And so it's kind of like that, but it's bounded within what I've called up until this point R3. And so, but then we get to a very, right, all fractions are ordinal numbers. I have that written down. And so it's very clear, right, if you say an exponent is to the nth power, and then a logarithm is also, a logarithm is an exponent, so that would make all logarithms ordinal numbers. And so that's a big, huge, obviously, connection. But we're still not even to like what I'm trying to set up here. And so then I have all fractions are ordinal numbers. But again, what is an ordinal number? Again, just one of these or this th, right? That's kind of what we classified logically and linguistically completely. And then now, right, you have a first place, you have a second place, you have a third place. If you have one thing, and then that's where this physical irreducibility comes from. Because now we're where we can talk about number fields. And so from a physical motivation, I do not like, if you're just saying, like people in physics, like Sean Carroll, Edwin, when they say a field, right, particles arises from fields everywhere. That's wrong. It's physically wrong. But I will say the words, or the phrasing, number fields. Because again, numbers uniquely represent things. And so, and things are discrete and they're irreducible to a certain level of fundamentality of these two physical components. And so, point being is there's first, second, third, logically represented with unique words. But then if you have one thing, and then you divide that by one, right, there's no word for that. If one is a denominator, there's no word equivalent to first. But for, 2 down there, as a denominator, you have half. And then 3 down there, you have a third. And so the only unique pairing between, again, I don't even know, because ordinal and cardinal don't really apply right now. But third, just the word, you have a half, you have a third, you have a fourth. You have a first place, you have a second, you have a third. And so the only repeated word in that is third. So I don't know what that is. That's some sort of consistency. That's something cool and useful in mathematics. But again, I'm trying to show you all of the steps. And so I can't even remember if I've done this, because the derivation, the linguistic rooting will all come back to certain things will pair up exactly, and they already have. But it has to be, to do a new axiom, you have to do new things. So I think at this point we're at completely new. I don't know, again, I keep saying I've done all of these steps. So I think we've probably already done this, but I don't know. But it's certainly, again, the intuition striking me, point this out in this explicit of detail. And so, again, you have a third, like a fraction 1/3, and then you have first, second, third. And then now, logically, third times a charm, right? That's not like logically that didn't strike you as, I did it one time, I did it 2 times, I did it 3 times, and third time was a charm. It strikes you as 3 multiplied by a charm, like a logical slang phrase. Third times a charm. So we just differentiated that logically with rhythm. Science. But something's going on here. So again, because this differentiation of first, second, third, placement. I do want to use the word placement here, and I'm being very specific with my diction. But then half, third, and fourth. So then back to the physical motivation of growth or evolution of functions. They represent physical systems. And so clearly if you're getting, right, infinitesimality is this half, third, fourth. If your denominator is getting bigger, that term is getting smaller. And so that physically represents if you try to divide something, there's a physical limit of sharpness, like what material can literally cut something else, and even past that to the atomic level. Up into the actual electron by electron, as you guys have seen in secret science team that nobody else knows about. But this third, logically, mathematically, is connecting something that definitely connects to, again, third times a charm, and then it pairs to this physical growth versus if something's getting smaller, right? It's finite, right? That's infinitesimality is finite. If you count first, second, third. Placement, those are your proper ordinal numbers. But if you're just saying 1, 2, 3, those are back to cardinal numbers, but again, it's getting bigger. It's representing growth, right? That whole, if you count all natural numbers, it equals, minus 1 over 12 is just some bullshit, some sort of, math game. Like, I don't play games ever, but definitely not, that's just like dumb shit. But then, what was I was going to continue that on a little more. Shoot, I just lost something that was cool. But anyway, it'll come back to me if it's relevant. But just the growth, because then infinity, I don't even say on the word infinity, but just sets really that are really, really big. I lost my train of thought. That stinks. But again, if it's you don't like lose big conceptual ideas, it'll come back to me when I'm talking about something. But right, a third time's a charm. That's definitely something. And then again, another logical thing, because it's like you don't have to like thread a needle. It's like you can't miss the big stuff. I just try to again articulate the intuition as it strikes me as well as I can for documentation. But a third wheel is one too many, right? And so it'll be spelled. That one will be spelled out on your screen. But you see what he did there logically. And so this third, right? What is third? Sensorality is thirdality. But again, clearly, I mean, that mathematics is lining up something big's there. What is the theme of a third? But again, it's so it's some sort of, again, that boundary of like growth versus rapid growth, infinite growth. Infinity doesn't really apply there. Much bigger, faster growth, exponential growth versus like addition. And so, because if you add a half, you add a third, you add a fourth, you're still growing, but you're just growing, and there is a finite amount or a limit you couldn't pass. And then, but if you're growing 1, 2, 3, but then how do that again? Then we're right back to being mathematics proper cardinal numbers 1, 2, 3. But then how does that pair to first, second, third? Because that is to placement, to order. So what's the difference between order and magnitude? Right, an order of magnitude. Order comes, right, order exists, or disorder exists, and then rhythm creates order, and then order existing produces chronology, or chronology, yeah, anything that ends in ology or is some sort of emergent or representation of logic. So order comes before chronology, or like chronology comes from order. And then magnitude is again in this, it's not as time dependent, because again, obviously everything right now is time dependent, but it's not a universal phase change. And so that's why it's just magnitude, because all of our units, so to speak, are decibels, or some comparison of vibration. Because that's what mass is. The big intuitive thing you need to realize is mass is stabilized vibration. That's the stability, like the little physical stability. But anyway, something's going on with a third. And so now then again, we have a direct physical motivation again for all number fields, right? Irrational numbers don't exist. It doesn't represent a unique thing. If I take my arm and I lose my arm, I'm still one Brad, unfortunately. But you still have one thing. And so you have no physical motivation or linguistic representation for irrational numbers. Right, and then literally you have that again. It's back. Third, irrational. What is going on? Science is going on. But I said after these big breakthroughs, and it takes me 7 years to like do a little bit of actual, or not. This is all again. The differentiations in the logic and linguistics is too like out there for you guys to see how poignant it is. But this is where we're getting mathematics is all derivative from logic, and so. What was I just saying again? Oh, things are all over the place. Oh, but there's no, again, irrational numbers. There's no irrationality, right? Order is rational, and everything is finite and terminates because objects are discrete. And then we have infinity, the physical awareness that there's just shit out there that we can't interact with. And so there's, again, this edge of the universe is not a valid question. And so, again, there's some sort of numeric iteration at 7 where it, like, repeats. But it's open. Again, we're demonstrating incompleteness, right? We're just stabilizing sensorality with the parts of linguistics that are available. So this is very poignant, even for me saying this shit out loud. And so I don't know what's going on, but that's going on. And then to the number fields, irrational numbers don't exist. The only number fields that even like kind of make sense to me would be the natural numbers, and the whole numbers. And then, that's what a fraction is it's not a fraction of one system. It's a fraction, or it's a comparison of two things, kilowatts per hour, this independent thing versus that independent thing. And so irreducibility is already contained within numbers or within words. And that's physical stability. And so, yeah, that's a lot of math. What am I trying to get to, though? Where am I going with this? Nobody knows. Actually, we do know. It's got to show the iteration of the C and the S, and sensors on your microwave, that's spelled with a C still. Yeah, I'm just kind of chilling. What did I just say, though? Like, the intuitions it's just all we're just all reducing stuff. And so again, what would be a whole number? So we derive fractions, like what it is physically, comparison of two independent systems. So why would rational numbers, why would fractions have to be represented by terminating decimals? Or why? So that again, that's why rational numbers terminate. That's because objects are discrete. We solved that something. We just did more math. Oh, but I did not even smoke the bong today. Not yet. But it honestly does. That shit doesn't affect me. I'm just excited. So for me to do all of this logic to be able to do some math is kind of fun. But again, the logical steps are so much more poignant. You just don't see them. But this is, like I said, I can know you guys are sitting there like, oh, what's going on? Math. Definitely math is going on. Numbers and stuff. But whole numbers, okay, what's the difference between a whole number and a natural number? I think they have to be like logically equivalent, right? There's no not whole things, right? So yeah, I would say immediately all whole numbers and natural numbers logically are equivalent. I don't know what alleged differentiation's been made in mathematics. Irrational numbers don't exist at all. Yeah, so that's what I got for there. I'm going to move on, not to dwell on it too long. But language is literal, meaning is literal. Sensorality is insularity. Sensorality insulates. Speciality is a sort of sensorality. So now again, we're building up this physical intuition, and then we have our variable sensorality ready to go, and we're just keep renormalizing all of our logic with these theorems. How does rhythm relate to hyphenation? Right? Very naturally, I put pre-meditation with a hyphen in there yesterday. It actually kind of like spells it out but I don't, Google Translate and autocorrect, I don't trust that shit at all. Because very provably, nobody can articulate what spelling is like as an algorithm, as a set procedure. That's what an algorithm is. But then again, is algorithms, back to just the standard differentiations, are algorithms, right? Logarithm, algorithm, right? Algorithms would have to be ordinal as well. Not trying to just continuing on where I can think. How does rhythm relate to hyphenation? Just another one of those linguistic pairings that are very similar, but logically isn't obvious. But you hyphen, right? Third times the charm. And so rhythm produces hyphenation. Sensorality is hyphenality. Hyphen, hype, right? You just take off the N and you get hype. Or no, you don't. There's an H in there as well. Close, but it's, again, the linguistic obvious. I'm done pointing that out. Algorithmicality is computer science. All right. Now we can generalize. What is computer science? What is that differentiation? Science is sentience. Linguistically, logically, we've proven that. We ran over that thing with a train like 6 months ago. Computer science, right? Are computers technological, right? Technological. Computation is calculation. So we just took a huge chunk. Again, we're rederiving all of number fields. So again, logically, I introduced it plenty fine. The word field, why does field make more sense to me when I'm talking about numbers as opposed to, definitely not physically, because you have discrete objects and temperature is not a field. Temperature is temperature. All of the vibration of things bumping into each other. But a number field, because you have points and then you have numbers that represent points, but those points are physical things. And so, yeah. I don't know. Again, I think we've done that step before, but it's certainly poignant enough to restate it. But again, it was definitely, again, articulated by me in a lecture as opposed to derivation, just the results over email. So we've derived number fields and like the fundamental difference of what physical differences exist to be represented by numbers. And so, yeah, irrational numbers don't exist, and whole numbers are natural numbers, and those are the only numbers. And then, very clearly, physically, numbers don't fucking exist. Drop down menu, drop down menu, drop down menu, drop down menu, and then when you try to root any function, you get back to 1/2 real because Riemann tried to think or something. Thanks for watching. See you on the next one.